So we're going to continue on with factoring polynomials, and now we're going to look at trinomials, so three terms in the form of ax squared plus bx plus c is going to be your trinomial where a, b, and c are numbers, and we can have positive and then negatives right there, but it's going to be something x squared, something x, and then our constant. And the first type we're going to look at is when our leading coefficient, that a value, is greater than 1. It's 2, it's 5, it's 17, or maybe it's negative. But if it is negative, that's where we're looking to hopefully pull out a GCF. At the very beginning, look at that step number 1, factor out a GCF or a negative if possible. We do want our leading coefficient to be positive, and if we can pull out a GCF out of everything, that'll help make our trinomial smaller and help us work through it to factor it. Step 2, we're going to multiply the a value and the c value. So we're going to multiply the leading coefficient and the constant together. And step 3, we're going to find those factors of that number that we just multiplied, a times c. We're going to find the factors of that add up to the middle b value. We're going to then rewrite our middle term to create 4 terms, and you can see step number 5, we're going to use that grouping method that we just talked about in our last lesson. So let's look at number 1. Number 1, factor completely 2x squared minus 5x minus 12. So this is in that standard form of a quadratic. We've got something x squared, something x, and then our constant. Like I said before, there's going to be positives and negatives in there, but we are starting where that leading coefficient is something other than an understood 1. There is a number there. So let's multiply a and c together. 2 times negative 12 makes negative 24. And I'm just coming over here to the side to do some scratch work, okay? So we are going to look for the factors. I'm on step number 3. Find the factors of that a times c. We got negative 24 for this one. That adds up to negative 5, adds up to the b value. So I'm going to put just a little note over here that I'm going to look for the factors of negative 24, and I want to find the pair that's going to add up to negative 5. So let's make a list. I'm probably not going to use 1 times 24. Another set of factors could be 2 times 12. We have 3 times 8 and 4 times 6, and I think that covers it. So go through the list, and we want to find the set that we would be able to add together to make a negative 5. Now, this was a negative 24. So I'm going to have to use a positive and negative in here somewhere. It's going to have to be like negative 1 times 24 to make negative 24, right? So I'm going to have opposite signs on these numbers, and then I also need it to add up to negative 5. So let's go through here. It's probably not the 1 and 24. It's probably not like negative 2 and 12, because that would only add up to a positive 10. Or vice versa, if I used positive 2 times negative 12, that gives me negative 10. 3 times 8, if I did negative 3 times 8, that gives me positive 5. But if I use positive 3 times negative 8, that's going to add up to that negative 5. So some things you might want to think about is the sign that you're trying to add up to is going to be the sign of your larger number. So when we did 3 times 8, the 8 is going to have to be negative for it to add up to a negative 5. So that's a little trick that you can use. Now we're going to take that 3 and negative 8. I'm looking at step number 4. I'm going to rewrite that middle term to create 4 terms. I'm going to split the middle, is kind of my favorite term there. I'm going to split that middle term. I'm going to rewrite negative 5x as 3x and minus 8x. I'm uncombining like terms. Let me show you. Keeping the 2x squared, I'm going to write plus 3x minus 8x and keeping the minus 12. So I just created 4 terms. I took that middle negative 5x and I uncombined like terms. I did not change the value here. 3x minus 8x is what? Negative 5x. So it's still the same value, but what I've done is created 4 terms. So now I can use that grouping method that we did in our last lesson. So now that I have 4 terms, I'm going to group the first half and second half together and look for GCFs in each group. I'm using the grouping method. So GCF in our first group, I'm going to use some extra notes here. Our first group, what GCF do we have? Just an X. So I'm going to remove the x, and that'll leave me with 2x plus 3. Second set of parentheses, GCF. Now remember, we want our parentheses to match. So if I'm going to get my parentheses to come out as 2x plus 3, I'm going to have to get rid of the negative. And they have a 4 in common. So GCF of negative 4 will leave us with 2x plus 3. Remember, your final step is take the GCFs and write that as a binomial. So we have x minus 4 times 2x plus 3 is our final factored form of this polynomial. Now, don't forget that we can also check our answers. We can FOIL this back out. First, outer, inner, last is going to give me 2x squared would be my first terms. My outer terms is going to give me 3 times x, or 3x. Inner, negative 4 times 2x is negative 8x. Oh my gosh, look at this. And then last terms, negative 4 times the 3 is negative 12. I'm getting back the 4 terms that I just had. And when I go and combine those like terms in the middle, I'm going to get that negative 5x from our very original problem, just working backwards and checking our answer. We did get right back to it. 2x squared minus 5x minus 12. But we were looking for this factored form. So x minus 4 times 2x plus 3. One more thing I want to mention is order doesn't matter. So if I end up with 2x plus 3 times x minus 4, that's fine as well. Let's do it again. Number 2, 4x squared minus 4x minus 3. We do have a leading coefficient, so I'm going to multiply 4 and negative 3 together to give us negative 12, just putting some scratch work here to the side. I need it to add up to negative 4. So let's list those factors of negative 12. 1 times 12, 2 times 6, 3 times 4, and I think that has us covered. Now, again, we are multiplying together and we got a negative, so I would need to have some negatives in here, like negative 1 times 12 or 1 times negative 12, but that's going to give me positive 11 or negative 11. I need negative 4. So what about negative 2 and 6? That's going to add up to positive 4. Let's do 2 times negative 6. That's going to add up to negative 4. That's the one that I need. So I'm going to take 2 and negative 6 and rewrite that middle term. Keeping the 4x squared, I'm going to write plus 2x minus 6x and minus 3. Now, some students might want to change this around. Instead of 2x minus 6x, I don't have to do that order. There's not some magic thing here. You can rearrange that. If you want to write the negative 6x first and then plus 2x, you can do that, especially if you start to notice some GCFs that might be easier. So let's continue now and use that grouping method. I'm going to group first 2 and second 2 together and look for those GCFs. GCF in our first group, we've got a 2 and an x. So we've got 2x. In the parentheses, what's left over? Another 2x plus 1. Wow. Second GCF. In the second set of parentheses, I need to get rid of the negatives there. So a negative and a 3. So let me write negative 3, and what will be left? A 2x plus 1. You see my parentheses are matching? So let's pull our GCFs together to make our binomial. And then our parentheses that repeated, 2x plus 1, I write that once. So there's our factored form. You can check it. You can use FOIL, and we would get 4x squared for the first. Outer is going to give me a 2x. Inner is going to give me negative 6x, and last is going to give me negative 3. Combining the like terms right there in the middle gives us a negative 4x and brings us all back to the original problem. So I just checked it, and it looks great. I want to go back to mentioning that you don't have to do that same order. You could do 4x squared minus 6x plus 2x minus 3, and you'll get to the same place. So when we were in the classroom, I would just choral call to the class, which one do you want me to write first? Do you want me to write 2x or negative 6x first? And just whoever said is the way we went. So if you want to rearrange it, you can. I want to show you that this is going to give us the same answer when I do grouping. Even though I switched the order here, my GCF is going to be a 2x here, and I'm going to have 2x minus 3 left over. Ms. Bryan, you're getting something different. Kind of, but it's going to come together just the same. This last part, GCF is just a 1. and we have 2x minus 3. And look how I bring it together. We're going to have a 2x plus 1, and that repeating parentheses, 2x minus 3. We got the same thing. The binomials are just in a different order, but because they're multiplying, multiplication is commutative. You can rearrange, for example, 2 times 3 is the same as 3 times 2. So now we're just working with binomials. The order doesn't matter. You can write whichever set of parentheses first. It doesn't matter at all. So you can see they're illustrated in orange. When you split the middle terms, you can rearrange that order, whichever helps you find those GCFs. All right, let's take a look at number 3. Again, we have 2x squared plus 9x plus 9. There is a number there in front, so I have to multiply the 2 times the 9. Scratch work over here. 2 times 9 is 18. And we are going to look for the factors of 18 that will add up to the middle term, 9. Now, 18 has factors of 1 times 18, 2 times 9, and 3 times 6. So I have a positive 18 here. The last two examples, they were negative. We had to work around positive and negatives there so that they would add up to that negative number. But this is the factors of positive 18 that add up to a positive 9. So it is going to be that 3 and 6 right there. Very straightforward, very easy. So let's try it now. We are going to rewrite that middle term. I'm going to leave 2x squared here. I'm going to write 3x plus 6x plus 9. And again, remember, if you want to put the 6 and then the 3, you can do that. So let's take our grouping method, find our GCFs. First GCF is going to be just an x, so we'll have x times 2x plus 3. Second GCF, 6x plus 9. I think they just have a 3 in common. So let me write that out to the side. And left in the parentheses would be a 2x plus 3. Hey, those parentheses are matching. So x plus 3 is one binomial. 2x plus 3 is another. There's your factored form. And you can check it by foiling. Number 4, 6x cubed plus 15x squared plus 6x. Wow. These numbers seem a little big, yes? Maybe you noticed here at the end, our constant is 6x. I thought a constant never had a variable. So some clues here. Remember, our step 1 should always be to check for a GCF. So what GCF would we have across this whole trinomial? We've got number-wise 6, 15, and 6. So while you might be tempted to pull out a 6, 15 does not have a factor that is 6. So we can't use 6, but we can use 3, right? They all have a factor of 3 that we could remove, and they all share an x. So let's remove a 3x from the whole thing. Now don't lose it. It's still part of our factored form because remember, we're factoring, finding the original things that were multiplied together to make this trinomial. So you don't want to lose this 3x. That's what makes it so big and ugly. So don't lose 3x. We're left with 2x squared plus 5x plus 2. Okay, check me on that. You could go back through and do distributive property, make sure you didn't miss anything. So now we're going to continue. Again, don't lose 3x, don't lose him, but we're going to factor the remaining trinomials. We still have a leading coefficient of 2, so I'm going to do 2 times 2 makes 4, and I want to find the factors of 4 that add up to a 5. So what factors of 4 do we have? 1 times 4 and 2 times 2. Which one do you think will add up to a 5? 1 and 4. Yes? All right, so rewrite that middle term there. We still have 3x. I'm going to let him hang out here. We kept the 2x squared. We're rewriting the middle term to 1x plus 4x. Or if you want to rearrange that, you can do so. Let's use the grouping method here. Our first set of parentheses, a GCF of an x, and we have a 2x plus 1 left over. GCF of the second group is a 2. We have 2x plus 1 left over. Let's rewrite our answer. Do not forget we had 3x at the very beginning. Pulling our GCFs together, one of our binomials is x plus 2. The other binomial, 2x plus 1. And that looks like our final factored form. Again, do not lose the GCF of 3x. you would have to be able to multiply everything back together to get our original problem. So if you lose the 3x, now your final answer is not going to get as big and chunky as our original problem. So 3x times x plus 2 times 2x plus 1. So I hope you were able to hang in there with us, guys. This is honestly, in my opinion, the hardest type of factoring. When you have a leading coefficient other than 1, you are going to love our next and final lesson on factoring. When there is just an understood 1 there, it is so easy. But we are still utilizing that grouping method. That's why I wanted to show you that first. It is the fastest way. From my memory, I believe Delta Math just uses a guess and check method. So I recommend the grouping method. It's a lot more straightforward. You're not guessing and checking for days. So if you do see the solution path on Delta Math, that's what it's doing. It's just guessing and checking to make it happen. So practice these, guys. Again, factoring is used throughout the remainder of our curriculum, and it's also going to be used in Algebra 2. So please, please, please take advantage of this time. Learn this. Students in Algebra 2, they want to send you all the encouragement to learn it now because they regret that they did not. So let me know if you have questions, guys. I'll see you in class and keep practicing.